Hello, VoiceOver Mike here. Just to remind you that SmartShow and Mike's LED Shed will be at the Plasa show at Olympia in London from September the 1st to September the 3rd, 2024. We will be in booth A32. Please come along, say hello to us, and you can get your hands on the SmartShow Pro-One LED controller. We'll have a live demonstration there with lights, so come along and say hello. Right, okay, a bit of a strange start to the video this time. This is part 2 of the LED prototype panels by SmartShow. So what I did with these panels is I mounted them on a board and I wanted to show you how this was done. So first of all, we're showing you the screws here. This is the back of the prototype boards, and this is a bit of tape just to hold them together as I solder the wires on the back of it. Here I am marking out the individual panels so I can drill the holes. This is for the wires at the back, so the board is upside down. I'm using a white felt tip pen here to mark out the panels. You can see the 4 dots for the panel, and then that allows me to work out the center of the LED panel. So each panel's got 4 holes for mounting, so you just use a white felt tip pen in all the 4 holes, and that allows me to find the middle. This is just a quick layout. As you can see, I'm making sure that my board is the right size, and you can see where I'm planning out the actual dots so I can drill the holes. The holes are for the wires that go in the middle. They are in the center of the LED panels. As you can see, the 4 holes there, and I'm just working out the center again, so I'm planning out on the board here where all the centers are so I can drill them in a moment. Just again, I'm just showing you where I'm planning out the centers. I did this quite a few times to make sure that I had all the centers checked and working. This is the full board now with the centers all sorted out and planned. Here I am drilling the holes and using my postable drill, just drilling the holes out. I can't remember what size drill I used there, but it made a bit of a mess, and I've actually killed the battery on my portable, so I've had to use an electric one, and I'm drilling out all the holes now. Quick wipe down with a sandpaper, and I'm now ready to mount the LED panels on the board itself. Close up of the hole there, and as you can see, I'm starting to put the bolts in. These are the M.2 bolts through the board, and here I am screwing the panels onto the board. Now I'll show you in just a moment what I put on between the panels and the bolts. This is the back. As you can see, the holes for the wires are in the center, and here I am starting to actually mount these now on the board itself, making sure that the holes for the panels line up so I can stick the bolts in. Got quite a few panels on there now. They're starting to get screwed into place, and you have to excuse a messy bench. So a bit of a close-up now of the panels, and as you can see, I'm putting them in with the bolts and starting to screw them down. Again, I'm just making sure that the holes are in the center. This is just to show you that I'm in the process of building it up. There we go, we're almost done, and then we've got the bolts in there, we've got all the panels on, and we're starting to put the wires on the left hand side. That was for the testing. And there we go, that is all the LED panels on the board now, and I'm starting to solder them up. Right, so this is my 3D printer, and what I did is I created a little washer using the 3D printer. Now the reason for this is when you put on the bolt into the LED panel, I wanted to make sure that I wasn't shorting out when I put the nut on the top, because all the sort of wiring for the individual LEDs is on the top. I wanted to make sure that I wasn't actually shorting out any of those connections. So what I did is I got my 3D printer and I just made a little washer for each one, and as you can see here I'm just printing those out. So I haven't put the image of this, or the pattern of this, is that what we call it? I don't know, on any of the 3D sites. This is quite simple to do. It's just basically just a washer that I printed off. Right, that's enough for me waffling on. Let's listen to some music. I'll be back to you in a minute. Okay, so it's coming to the end now. It's almost finished, and you'll see in a second all the little washers that I printed off. There we go, they're all done. Right, next thing I need to do is to start to solder some of the connections up. So this is me, and I'm just soldering between the panels the plus 5 volt trace and the ground trace and the signal trace, and I'm just doing it across the board just so that the power and the signal can flow from left to right across the panel. And it's just as simple of just using I'm just using my magnifying glass, and as you can see I'm just going from top to bottom, just soldering up all those connections. Right, that's enough for voiceover mic. I will pass you back over to live mic in a minute. Okay, so far so good. Thanks to voiceover mic for the voiceover, what do you call it? The commentary, that's what the word I'm trying to think of. Thanks for the commentary so far. So where are we with the matrix? Right. Okay, so first of all, this is the matrix board so far. These cables on the end here are for testing, which we'll have a look at in a minute. All the squares are on there. Don't forget these are 1 universe each. So we've got 1, 2, 3, 4, 5, 1, 2, 3. So we've got 15 panels across there at the moment. They're held on by these nuts and bolts which are going through here, so they're all quite sturdy, flat to the board. On the reverse side you can see that we've got cables in at the moment. These are the power cables, 1, 2, 3, which I've soldered through the holes at the back. So they're on the end panels here, and you've got access to all the panels here, so you can power inject or put your data into any of these. But what we'll do at the moment, first things first, is that what I want to do is do some testing. So that's why I've soldered these cables on the end here. What we'll do eventually is we'll connect them on the underside, but just for the time being I want to do some testing. So I have to confess, I have tested this before I started recording, because I got ahead of myself and I said, no, I've got to stop, I've got to demonstrate to you how it's working. So I'm just going to connect the SP110E connector controller to it at the moment. We've got power on over there as well, so let me just show you. So we've got power on here, and we're also running from the transformer back here as well. Okay, so let's power on. Okay, so we can see that all the LEDs are working here on this particular row here, so that's okay. I can't see any LEDs that are out, but we'll do a colour test later on. the next row. Again, that's all connected up, so the links are here. So we're linking the power, the data out and the data in, so we've got data going across that one as well. And finally, this one here. Again, we've got power going across on the connections, and we've got data in and data out, linking all the way across. So we know that that one is working as well, so that's okay. So because the panels are keyed, it means that we can make sure that these are all the right way around. What I haven't done yet, and what I might look at in the future, is soldering between the rows here for the power, but we can come back to that later and have a look at that later as to the way that the power is being distributed. So what's next? Well, I think the next thing we need to do is to get some cable out the back, out the drawer, and then we'll remove these three here and solder them, the power and the data, from the back of the board to hide all these cables, and they'll come through the circuit boards there. So that's the next job. Right, next thing we need to do then, I've got these cables connected underneath, by the way. Well, that feels a bit loose, might need to add another, got a bolt there, but I think I'll add another bolt just there. Anyway, that's future. So we need to put the female ends onto these now, these JSTs, so let's put a bit of thick heat shrink, which will go over all the cables when they're done. Okay, and we'll use a bit of a normal heat shrink to go over the individual ones. So that one can go onto there. Right, a bit of solder can go onto that. Solder stuck, hang on a minute. There we go. Right, as I said, a bit of solder goes on there. Okay, now we're going to have to wait until that cools down, because the last thing you want to do is put heat shrink on while it's still warm. Okay, right. Hopefully that's cool enough. Let's slide that over. That's it. And we'll get the hot air. Right. Now I've got to do that 3 more times, 2 more times for these cables. That's the power, the date on the ground, and then I'll put the big one over the top as well. Right, let's do that. Right, that's got all the ends done. 1, 2, 3 ends done. Now, here's the thing. I just had a thought when I was soldering the last one. You may be thinking, well, why are you bothering to put these ends on when you can actually just use the screw connections on the controller? We can put screw connections, which we'll see later. Have I got one laying around? No, I haven't. Well, yes, you can do. What I'm going to do is use some connections, metal connections, to plug onto this, purely for a quick, easy removal and changing of things, because I'm not entirely sure yet what this grid is going to go onto. So I might need to put it through other holes. I might need to build a frame or something like that. So that's why I'm putting these on for the time being. But anyway, things may change, because it often does. Right, that's on. We just need to do a quick test to make sure that my soldering skills are up to standard. So that's the first one. That's okay. Just turn off that. There we go. Right, so that's the first one. That's okay. That's the next one. Yep, that's okay. So that's all done. And the third one goes on there. Still using this little tester here with a dodgy. That's the power that goes into the back of this, making it flash, by the way, in there. So, but yes, that's working okay as well. Good. Right. So we now know that we've got power signal cable going in, which are here. We've got power injection at the back, which is behind here at the moment there. So I think the next thing we need to do is get it all connected to the power, which is going to be provided. Oops, cable in the way. So power is going to be connected to here, to this block here, which so we can keep an eye on the amps. And also we can connect it to our controller here. So we're going to use the first 3 outputs, A, B and C. We're going to make sure that we're grounded as well. Power goes in here, network goes there, and then we can connect it up to Jinx and get some pretty patterns going. So that's the next job. Okay, so you should be able to see the screen as well as a grid. So let's go to the controller. And what we need to do, the site can't be reached. This is because the controller is in what's called extended mode. And if it's in extended mode, it's giving out 32 universes. So we go to the controller, we press the little joystick button on the side here, we keep it pressed, and then what it'll do is we'll go into C, which is configuration mode. So let's just try that again. And there we go, we are now in the full mode. Right, okay, now we're in the full mode. Let's do some testing. Let me just very quickly explain what I meant by the extended mode. So if we go into output configuration, it says here we're in extended mode. And when you're in extended mode, the only way you can get into configuration is pressing the little joystick and go into the C. What I'm doing, because it's in extended mode, can output all the universes here. I can go up to 32, and as you can see, I've been using other LEDs here, so the APA 102 and the SK6812, which is green, red, blue and white for the other outputs. Now don't worry too much about those at the moment, they will become clear later on because I show you what I've been doing with those. Also down here we've got DMX as well, so the last two channels on the controller are also outputting DMX to some lights, and again don't worry about that, either this video or the next one, depends how long it drags on for. I'll explain what all that's for. So at the moment all we're interested in is pixel testing. There's two things that you need to be aware of on this. Pixel testing will use the default configuration, so the default color output is 213 at the moment, so that makes sure that we get the red. As you can see, we now have red, and the green and the blue. That is extremely bright, so what do we need to do about that? Well, let's go into one of these. I can't remember which one it is now. There it is, and we can change the brightness. Now I'm only on 15% at the moment, so that is still quite bright for our test. So I'm going to drop that down to 10%, apply that, and then I'll just try that again. There we go, that's a little bit better. So there's the red, there's the green, and there's the blue. Hopefully you should see that on the camera okay. So we now know that all the LEDs are absolutely working fine, and we've got nice power outage. And what I mean by power outage, okay, let me just quickly go on to it again. There's the red, so there's no discoloration. I don't know if you can see that on the camera, I'll have a look in a minute. But as you look at the whole matrix, all the LEDs are in the same brightness. There's no dim of LEDs. So what that's telling me is that the power from both sides is going through the grid without any problems. If I look at the amps usage on the side on the desk, I'm using 1.3 amps at the moment, so it's not using much. Let's just go to the green. Okay, now that goes up slightly, it goes up to 1.38, so a little bit more, just short of 1.4 amps. And if we go to the blue, again it just drops down again to 1.37 amps, so about 1.3 amps. There's not a lot being used there, but again I'm only using 10% of the pixel brightness on the screen here. Okay, so that's the testing done. Let's switch that off. Right, before we go into Jinx, let's have a quick calculate in Excel. I use Excel because it's easier to calculate my totals and make sure that we've got the layout right. First of all, we know each panel is 13 times 13 LEDs, so let's do a quick calculation on that. 13 times 13 is 169. We've got 5 columns and we've got 3 rows, so we've got equals 5 times 3, so we've got 15 panels in total. If you want to know how many LEDs in the row, we've got 169 LEDs per panel, and we've got 5 columns. So to make a line we need to calculate that. So 169 times 5 is 845, and if you want to know how many LEDs per column, we do 169 and we've got 3 rows, so that equals 169 times 3 gives us 507. And if you want to know how many LEDs in total, so we've got 15 panels and we've got 169 LEDs per panel, so that equals that times that, gives us 2,535 LEDs in total. We know that our amps is 0.06 amps per LED. So if we do equals the total number of LEDs times the number of amps per LEDs, comes to 152 amps in total. Now that is 152 amps if every single LED, the red, the green and the blue, are all on full white. You'll need 152 amps. Now, as I've been talking, you see that there's been some patterns on the screen, on the LED screen, and I've been averaging just under an amp. So let's say 1 amp in total. Now, why can you say that all the LEDs are 152 amps and I'm only drawing 1 amp? Well, let's look at the matrix. Most of the LEDs are off, and some of the LEDs that are off will only be showing one colour. Now, we've got a video playing now, but again, you look at that and you go, well, most of the LEDs in the middle are not switched on, and the LEDs around the outside are switched on, but the various colours. And if I look at my amperage, again, at the moment, we're only pulling about 1 amp. So bear that in mind. You've got the brightness of the amps, you've got the brightness of the LEDs, plus you've got how many LEDs are actually switched on, and if they are on, how many colours is it showing. So on my transformer, which is 60 amps in total, I can run that LED absolutely fine. I can run the matrix absolutely fine because I'm not pulling 152 amps. You would never ever 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 go up to 152 amps. That would just melt the cables and everything. So just be very careful, make sure you got everything fused as I've shown you, and then you'll be absolutely fine. So let's just have a look at these two matrices that I've made on Excel here. So number of LEDs in the layout. So this is the way that the LEDs are wired on the panel. So it starts in the top left corner and it goes down that way. Okay, and then it crosses over to there, and then it goes up that way. So this is called snake by columns, or it's also called zigzag. So this is a zigzag by columns. So we've got 1 to 169 LEDs. So if we want to look at the channels, the start channels, so what this is doing is times in that number by 3. But just to make things a little bit more awkward, the ArtNet channels start on 0 instead of 1. So that's why I've got 0 in that corner there, number 3, number 6, number 9. So that's the first channel for our RGB. So the red on channel 2 there is going to be number 3, and then the green is going to be 4, and then the red is going to be 5. Sorry, blue is going to be 5. And again, I've zigzagged that over here, and you'll see why this is important to plan it out when we go onto the onto Jinx, and we can check all these numbers on Jinx. What you can also do while you're in Excel is plan out the whole thing as well. So this is my whole matrix. So we've got 5 panels across, we've got 3 panels down, and when I patch it in Jinx, you can see that I've got the universe numbers there. So universe 1, universe 2, universe 3, etc. So I can plan out in Excel where my different universes are and where my panels are. Okay, I hope you got all that okay. Let's have a look inside Jinx then. Right, as you can see, we're in Jinx now, and we've got an animation of a skull, which is an animated GIF, and we've got the fire in the background. Okay, let us just stop that, and let's quickly go into the matrix options, and we've got 65 times 39, which gives us 2,535 LEDs in total, which matches our Excel spreadsheet, so that's good. We need to set the output devices, so don't forget we've got 5 times 3, which is 15, and the universes start at 0, so we've got 0 down to 14, which is 15 outputs, so there's our 15 universes, and you can just simply untick that box, type in the IP number there, make sure run outlet, and the universe number is there, and you can just do 1 2 3 4 etc. So all those are in there, and then we need to patch. I'll do a link to one of my other videos where I show you how to patch, but if you remember in Excel, which I'll bring up now quickly for you, we looked at the patch numbers here. So first one is 3, first one is 6, first one is 9, etc. So we've got 0, which is there, and then we've got 3, which is there, 6, which is there, etc. We go down to 13, and so that's 36, 37, 38. Next one across should be 39. There we go, 39, 40, 41, and then we back up to the side, and we do a zigzag across like that. When we do a fast patch, what we do is it is 13 by 13, and we do snake columns top left, and we select the universe, and then we patch it, and that will patch go down that way, across, up that way, like that. And as you can see, I've patched the whole matrix here. So the last one in the bottom corner is 506. Let's have a look. 504, which is the 3, and that gives you it. So that's okay. 504, 505, 506. And that's what you do. So let's start the output again. So assuming everything's done, and then that's when you get the output like that. So there you have it. That is the setup of our LED matrix. We've got the SmartShow Pro-One controller here, which is only using the first 3 outputs of this controller. We've got a matrix which has got 5 LEDs across the top, and we've got 3 rows, so we've got 15 of the prototype LED panels here. You can't see where the link is, because don't forget that they're all keyed, so they can go side by side without any gaps. And we've got matrix working with Jinx, and it's as stable as anything. I hope you've enjoyed those 2 videos, the previous one part 1 and this one part 2 of the SmartShow prototype LED panels. Don't forget, we're going to be at the Plasa show in September in London at the Olympia. Please come along and say hello to us there. And if you like what I do, please give me a thumbs up. It helps with the I mean, I don't get paid for doing this on YouTube. I just do it because it's a bit of fun, and everything that I show you I buy as well. So the LED panels were donated, and so was this. I haven't bought those 2, but then I haven't got anything for the advertising either. Okay, yes, if you like what I do, please give me a thumbs up. And also, all this waffling on, all this talking makes my throat dry, so if you can, please buy me coffee, which is, the link is down there. Thanks very much for watching. I've got a few things lined up for my next video, which includes this mystery box here, so looking forward to that. We've got some Sinclair Spectrums to look at as well. Thanks for watching. See you again soon. Bye for now.